Today we will discuss eddy currents. This is also known as the Foucault currents. The induced circulating currents produced in a metallic block itself due to change in magnetic field or flux linked with the metallic block are called eddy currents. So, eddy currents in a metallic block placed in a non-uniform magnetic field perpendicular to the plane of the block, and the eddy currents in a metallic block moving perpendicular to a uniform magnetic field. Now let us see. Suppose this is a metallic block, and when it is kept in a uniform or non-uniform magnetic field, and if this magnetic field is varying, changing, then we will see a current circulates in the magnetic block, and we will see due to different strength of magnetic flux we will find different circular magnetic current. So these are eddy currents produced in this magnetic field due to varying magnetic flux or magnetic field through it. Now the question arises here, what is the cause of eddy currents? So when a metallic block is kept perpendicular to a non-uniform magnetic field or flux moved perpendicular to uniform magnetic field, the magnetic flux through different parts of the metallic block is different. The change in magnetic flux gives rise to induced EMF across different parts of the metallic blocks, and hence eddy currents are induced. These are concentrate in the metallic block. The direction of the eddy currents is such that they produce the metallic magnetic field which opposes the applied changing magnetic field as per Lenz's law. Now we will describe here some experiments. First of all, we will see the flying metallic disc. Now this is an electromagnet. And the coil on the magnet, it attached to a varying source of electricity. So current is always changing in this coil. So if an aluminum disc is placed over the core of the magnetic or electromagnet here, this is here the placed here. So when circuit is closed, the changing current flows through the circuit, and this disc jumps up to a certain height or fly away from the core of the electromagnet. We will see when current flows here, then we will see north pole and south pole is formed. Suppose it may be south here, north here, and we will see according to Lenz's law, in this metallic block a current is circulating, eddy currents, and here on this one, this side, on the lower surface of the aluminum disc, north pole is created, and in the upper surface south pole is created. So when the current applies here, we will see due to repulsion between this north and this north, they repel in this direction. It jumps here up to this height. We will find that certain height, and it comes back on this one like that. So this happens due to production of eddy current in the metallic disc. This is the flying disc experiment. Now we will see the damping of oscillating metallic plate. If suppose this is a metallic plate and it is kept in a magnetic field created by two strong magnets, poles of the magnets, and we will see if there is some varying current. We will see that if it is suspended through a string, we will see due to the eddy currents in this one, we will see it oscillates and it will not in the equilibrium position. Then to remove this damping, we will use this metallic plate slotted like that. Like that. Now eddy currents are produced in this one like this, and we will see the direction of current is like that here. So we will see these opposite currents, they repel the effect of each other. So when this oscillating plate is suspended between the two pole pieces of a strong magnet, the plate comes to rest in a very short interval. This will be used in the galvanometer and other devices when we will see this. Now, second thing, advantages. We know very well that it is used in induction furnace, speedometer, deadbeat galvanometer, electromagnetic brakes in electric train, then in energy meter, induction motor, induction cooking. Now we are going to see here the disadvantages. What are the undesirable effect of eddy currents? First of all, the production of eddy currents in a metallic block leads to the loss of electric energy in the form. So we will see that substance, that element, that particle becomes heated, and this is here the loss of the electric current which is used. Now heat produced due to eddy currents breaks the insulation used in the electrical appliances. So in each and every appliances, insulated wires are used, suppose in motor. Then some eddy currents are produced. In transformers, some eddy currents are produced. We will see that due to the heating effect, in temperature of that part, that element increases, and we will see that insulation becomes poor during course of use. Eddy currents also produces unwanted damping effect. These are the disadvantages. So the question is now how to minimize this loss of heat. So minimization of losses due to eddy current. So metallic cores are used to electrical devices like transformers, dynamos, choke, etc. Due to changing magnetic field, large eddy currents are produced in the core, which causes large amount of heat in the core. So it results into loss of useful energy. So first of all, we will see, this is here a solid core. So we will not take the solid core, we will make it laminate. That means we will make this core of many thin sheets, and all these sheets are riveted. This is here one sheet, here is a hole, two holes are made on the one plate, and on this one keep the another plate, then another plate, then another plate, and make it thick. And here now from these through holes we can rivet it. So we will see in each and every plates there is the induction of heat, but we have to take precaution here. We have to insulate all these single lamination. So here is the one plate, over this one plate there is a one lamination between these two plates. So we will do to minimize the losses of heat like that here now in the next class.